Okay, so basically, we have to discuss the detail of a skeletal formula. See, this is one carbon, single bond, another carbon, single bond, another carbon, single bond, another carbon. This is actually butane. Now you can fill rest of the bonds with the hydrogen. I mean, now I'm going to discuss skeletal formula. We don't need um, hydrogen in skeletal formula. Okay, so one, two. I mean, corners means carbon. C for corner, C for carbon. I mean, these are the tricks by which you can remember the skeletal formula. One, two, three, four. I told you, F for fracture, you have to show every fracture in a skeleton. So F for functional group means you have to show every functional group in a skeletal formula. And then you have to show a double bond is also considered the functional group. So you have to show double bond also. H for, I mean, hydrogen bonding. H means hemoglobin. Hemoglobin is usually present in blood. We never show blood in a skeleton, so you don't have to show any hydrogen in the skeletal formula. And what about carbon? The corners, C for corner, C for carbon. So these corners are actually showing your carbon. These are the corners now. So you can see there are four corners, means this is the butane, but definitely you have to show your butane like this without any dot or something or any mark. Okay, so let me tell you. For example, if I say that I have a double bond here, this is not butane, this is butene, for example, then so you can see second carbon or the third carbon. So you can check your group. This is second carbon, this is third carbon, and there is a double bond. See, so you can make your double bond here because this is my ferrous structure. Okay, this is my ferrous structure. So you should consider this one. Okay. All right. Next one is, for example, let's add some more things here. We haven't discussed about the functional group yet, but I'm telling you here, after that, whenever we discuss any structure in organic chemistry, I'll let you know about the structure formula and the skeletal formula of that compound at that time. We are not wasting that much time on the skeletal formula, but let me tell you about the basic also. For example, if OH is attached here, see, if OH is attached here, this is a functional group now. Functional group fracture. Every fracture should be shown in a skeletal formula. So functional group will be shown in a skeletal formula. So where is OH? Second carbon. This is the second carbon. You have to show OH here. Let me show in the real structure. You have to make a smaller bond type like this, and then you have to show your OH here. This is how you have to make your your skeletal formula. For example, if this is pentane, I just added one more carbon. So you can draw like this, 1, 2, 3, 4, 5. And you can see there is a double bond. Now you have to show double bond here. And here you have to show OH. This is so simple. Okay. Other than this, for example, if OH is attached here, not above, not below the carbon, then so what you have to do, let me show with the red color so that you could see it. See, you have to write here OH. You can do like this, or there's one more way. There is one more way. You can do like this. This is also acceptable. You can see that there is last carbon which is joining OH. You can do like this also, or you can attach OH directly. That's not a big deal. This is your skeletal formula. This is the basic of a skeletal formula. You know, these are the basic compound. When we will discuss about the organic compounds, like aldehydes, like benzene, means arene, like nitriles. We have a lot of functional groups here. We have a lot of organic compounds here in A levels. So definitely every compound has different and complicated skeletal formula. So this is all about the skeletal formula. Let me tell you about the functional groups now. These, which type of functional groups do we have in organic chemistry of A levels? So what are the functional groups? Functional groups can change the chemical properties of your compound. Let me remind you one thing. We just discussed some carbon chains, like shortest carbon chain and the longest carbon chain. Longest carbon chain or the shortest carbon chain. If you are making your chain longer, it can change the physical properties of the compound. Like this is ethane. It has different physical property. And what is this? 5 carbon, single bond, pentane. So different physical properties. Pentane, more carbon, more bonding, more force of attraction between the particles. It could be solid, it could be liquid at room temperature. That's what we have to discuss in upcoming classes. Well, let's move to the functional group so that you can learn the functional group for upcoming classes, because without learning functional group, you cannot make any single reaction of A levels organic chemistry. So let me show you what are the functional groups we have. The one or the first, which is the easiest, and that is the double bond. That's what I was telling you, that double bond is also the functional group. Double bond is also considered as a functional group. When carbon is joining another carbon with the double bond, so you know very well that this is called alkene. This is alkene. And one more thing, what is the name of this compound? Ethene. Ethene. And I guess that's it for this one, because this is the easy. Or let me tell you one more thing here, because in A levels we have already discussed about the shapes of molecules, which were not included in O levels chemistry. So in A levels we have already discussed the shape of molecules. So you have to focus on the shape of molecules. See, this is ethene. Carbon is making double bond with another carbon. So in ethene, you can see 1, 2, 1, 2. Or you can follow the Lewis structure or dot and cross diagram. Sorry. So yes, this is ethene. So now both the carbon are having 2 unpaired electron now. So it's, I mean, usually we are using this structure: 1 hydrogen, another hydrogen. Okay, 1 hydrogen, another hydrogen. This is ethene. I forget to tell you the journal formula of alkene. That is, I mean, for alkane, it was CnH2n plus 2. This was for the alkane. For alkene, you don't have to write this plus 2. So for the ethene, it will be C2H2, and for N, you can write 2 here. So you will get C2H4, and you can see this is C2H4. This is the journal formula of the alkene. So this is ethene. So let me tell you the mistake here. Basically, now we have done with the shape of molecule, and you know very well about the repulsion between bond pair and the lone pair. Basically, in carbon, you will never see any lone pair. No, carbon doesn't have lone pair because it always it has 4 electron. It will make 4 bonds. So you can see all are bond pair. I mean, this is a bond pair. 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 All are bond pair. So there will be equal repulsion. So all the bonds will arrange them to in a specific shape to minimize the repulsion. So you can say that hydrogen will be there. If you remember the shape of molecule with 3 bond pair, with 0 lone pair, so you have to draw like this. You don't have to focus this hydrogen. Can you tell me the shape of molecule here? There is no
I
lone.
think it's tetrahedron.
Tetra means 4. 4 bond pair, 0 lone pair. Tetra means 4. Tri means 3. Trioxide 3. Trigonal planar. 120 angle. 120 angle, 120 angle, 120 angle, 120 angle. Trigonal planar. Is it clear to you?
Yes.
So when you are working with the organic chemistry, you don't have to forget the physical or analytical chemistry something reason. You can see. They can ask you, I mean, the paper, there are no two different papers of organic or inorganic or physical chemistry. So you should know about the shape or hybridization or everything. You should know about everything here also. Okay, let's back to the functional group, because that's what we have to discuss in structures. Okay, so the first and the easiest functional group is alkene, which is also called I mean, here we have 2 carbons, so the name will be ethene, propene, butene, hexene. It depends number of carbon. No? Okay. Let's move to the next functional group. Alkene is the easiest one. Let's discuss the one more easiest one, which is alcohol. Wait. Okay. Let's discuss alcohol because you're already familiar with the alcohol. Alcohol means 2 carbon, and there could be OH attached. There could be 1 OH, there could be 2 OH, there could be 3 OH. It depends. The chain will be changed. I mean, the name will be changed, but actually that will remain alcohol. So what is this? Alcohol. Functional group is alcohol. And what is the name of this compound? Because you should know that how to write the name. This is ethanol, butanol, propanol. It depends now that how much carbon you are using. This is ethanol, alcohol, ethanol. Okay. Let's move to the next one. There are a lot of functional groups. Haloalkanes. Haloalkanes. Okay, haloalkanes. There is carbon. I mean, there's a hydrocarbon chain. Let's work with 2 carbon. For example, there is any halogen attached. There could be any halogen. There could be chlorine. There could be iodine. There could be bromine. Mostly you will see chlorine and the bromine in organic chemistry. And now you should know the reactivity series also. Organic chemistry is not totally the I mean, you cannot say that organic chemistry is separate portion of the chemistry. No, it is linked with the physical and analytical and the inorganic chemistry. You should know about the reactivity series. You should know that chlorine is more reactive if you are going to attack this compound with the bromine. So you should know something will happen or not. That's what we have to discuss in upcoming classes. So you can see when you have any halogen group attached with your, we usually show halogen with X. X means any halogen. X means any halogen. It could be chlorine. It could be a let me write it here. X means any halogen, means chlorine. It could be bromine, it could be iodine. You know very well, we are not using fluorine just because of the electron negativity of fluorine. It will make your compound more polar, more stronger. And we don't need that much stronger compound in organic chemistry because we are going to break some compound sometime. We are going to attack the compound with anything to get new compound in organic chemistry. So we are not using fluorine. So you should know X means halogen. And what is the name? Haloalkane. This is the alkane, na? Haloalkane. Haloalkane. And what is the name? For example, this is ethane. So you can call it haloethane. Haloethane. Or it depends, na? Halo means halogen. If you have attached chlorine, so you can say chloroethane, or you can say bromoethane. It could be chlorobutane, it could be chlorohexane, it depends. So this is the haloalkane. This is the easiest one also. Now, let's discuss one more. Okay. There are 4 more which are more difficult. So before that, let's discuss the arenes. Okay, arenes is definitely new for you, arene, because it was not included in O levels. Arenes. What is arene? Aromatic compounds. What are aromatic compounds now? Ring structures. Ring structures. Example is benzene. I'll tell you the structure. Benzene. You will see benzene in a lot of reactions of organic chemistry. You know, it took me 4 classes to discuss benzene with the students. Benzene is the example of arene. I mean, this is the compound name. Benzene is the compound name. And the whole group name is arene. What are arenes now? Let me show you here. We just discussed about the hexane. Hexane means 6 carbon. How many hydrogen could be there? You can make a chain of 6. You can make a chain of 6 carbon, and you can fill rest of the bond with the hydrogen. You will come to know about the formula of hexane. And the other option is journal formula of alkane, because I'm asking about hexane. So CnH2n plus 2 will give you the formula of hexane. Let's drive the formula. You can use the structure also. So C6, okay, and hydrogen. 2n, n means 6. So 2 multiplied by 6, 12, 12 plus 2, 14. So 6 C6H14 is actually hexane. Okay. What about hexene? I mean, this is hexane. This is hexane. I may ask you about hexene also, because we have to discuss one structure, hexane. This is hexane. What about hexene? That is not difficult also. Hexene means there could be one double bond between the chain. So you can make a 6-carbon chain and you can make one double bond. Then now you can try to fill hydrogen, and you have to fill hydrogen carefully so that you could check that double bond. Or you can use the journal formula of hexene, alkene, which is CnH2n. This is journal formula of alkene. So you will get C6 H2n. N means 6. So 2 multiplied by 6 will give you H12. Carbon is making double bond with another carbon in this compound. So definitely you have to remove 2 hydrogens. See? So this is hexene. Is there any confusion in this compound?
Could you please repeat this?
Hexene, I mean, what type of confusion do you have? Are you unable to understand about hexene?
I mean, what are you doing here? Are you converting hexane to hexene?
I'm not converting. I'm just driving the formula. I'm just telling you that
Oh.
there is one alkene. I mean, if there are 6 carbon in a chain, so you may, I mean, it could be hexane or it could be hexene. For example, if I tell you that Zainab, I have a carbon chain which has 6 carbon. So tell me, what could be the name of that carbon chain? So definitely you will ask me, Miss, there is single bond or the double bond? If all the
Yes.
carbons are joined with a single bond, so you will say, Miss, this is hexane, and you can find formula in a second. You can make 6 carbon and you can fill all the bonds of the carbon with the hydrogen. You will get the formula of hexane, or you can use this journal formula of the hexane, which I used here, and you can easily find the formula of hexane, which I just found, which is C6H14. This is the formula of hexane, but it could be hexene also if there is a double bond. Let me show you the structure of hexane. See, 1 carbon, 2nd carbon, 3rd carbon, 4th carbon, 5th carbon, 6th carbon. But this is hexene, so you can make a double bond. Now you have to fill hydrogen. See, 1 hydrogen, 2 hydrogen, 3 hydrogen, 4, 5, 6, 7, wait, 8, 9, 10. 10, okay. Now see these 2 carbon. I mean, you can see 1, 2, and 3. 3 electrons of the carbon are already paired. So you have to attach 1 hydrogen only. This is 11th hydrogen. What about the next carbon? It is already making double bond with the previous carbon. So 2 electrons are paired already, and third one is paired with another electron of the another carbon. So it has only 1 unpaired electron. So you can attach only 1 hydrogen here. You cannot attach 2 hydrogen with these 2 carbon, which are involved in a double bonding. So you can count. You are getting C6H12. So if there are 6 carbon in a chain, it could be hexane, it could be hexene. There are only 2 possibilities because we are not going to discuss hexane, the triple bond. So if I say that, Zainab, I have 6 carbon in a chain, what could be the formula? So you can tell me, Miss, it could be hexane or it could be hexene. It may have 12 carbon, it may have it may have 12 hydrogen, or it may have 14 hydrogen. It depends on the bonding, but there are only 2 possibilities. If you have 6 carbon in a chain, so there are 2 possibilities. The formula could be C6H14 or the formula could be C6H12. If that is hydrocarbon, means there is no any oxygen, nitrogen, sulfur, or anything is not attached with that chain. I'm talking about hydrocarbon. So if this is hydrocarbon, and if the hydrocarbon chain contains 6 carbon, so it could be hexane or it could be hexene. There are only 2 options. So the formula would be C6H14 or C6H12 only. There is no any third option. Is it clear to you now?
Yes, it's clear.
Now see, we just found a new compound of 6 carbon. We just found a new compound of 6 carbon, and let me show you the structure of that. I mean, we just found a compound and the formula is C6H6. This is the formula. Yes. Actually, we have mass spectrometry and different techniques by which we could find the formula of the compound. So we just found a new compound and we just found that the formula is C6H6. Now we don't know that which type of compound is this. You can see this is C6H6. If you see C6 means hexa. It is not hexane because for hexane, the formula should be C6H14. And this is not hexene because for hexene, the formula should be C6H12. Are you getting my point?
Yes.
Okay, so let's try to make its formula. See, there are 6 carbon. And what does it mean? 1, 2, 3, 4, 5, 6. Okay, what does it mean? Let's make few double bonds. We can create more double bonds now. Now, how many hydrogen do we need? Here we need 1 hydrogen. Here we need 1 hydrogen. Here we need 1 hydrogen. And here we need 1 hydrogen. Okay. What about the last carbon? It needs 2 hydrogen. Both the corner carbon need 2 hydrogens. So 8 hydrogen should be needed here still. How can we make a linear structure with 6 hydrogen? Impossible. Linear structure of hexa type of carbon chain means linear structure of 6 carbon. If it is hydrocarbon, means no other element is involved. Only hydrogen will be there. So hydrogen can make single bond only. So this is impossible to make a structure of 6 carbon with 6 hydrogen only. So we can say the linear structure is not possible, but we just found a compound and we just found that the formula is C6H6. This compound exists. So we have to work for its structure. So what we did, we just convert it into the ring structure. See, this is a carbon joining another carbon, joining another carbon, joining another carbon, joining another carbon, 1, 2, 3, 4, 5, 6, joining another carbon. This ring is something like this. I'm telling you about a skeletal formula. This is skeletal formula. Na? Corner means carbon. Corner means carbon. Okay, back to the normal structure. Then we will discuss about the skeleton one. Okay, see, there are 1, 2, 3, 4, 5, 6 carbon. Okay, and there are 6 hydrogen. But wait, there is alternate double bond, you can say. Now you can check the bonding of the carbon. That's what I just did in linear structure also. But still, I was getting 2 extra hydrogen, and there are only 6 hydrogen. I need 2 extra hydrogen. If I was making this whole stuff in a linear structure, I just made this whole stuff in a linear structure with 3 alternate double bond. But this is a ring structure. For example, let me show you. For example, this is the first carbon, and this is the last carbon. And now you can see the first and last carbon are making bond together. So they don't need hydrogen. They are making bond together to minimize the requirement of hydrogen. That's how I could make it easy for you. 6. Now you can check the bonding of every carbon. Every carbon is making 3 bond with another carbon. With neighboring carbons. Or you can say for every carbon, 3 electrons are unpaired. So you can say every carbon has 1 unpaired electron. You can check. Every carbon has 1 unpaired electron. Is that clear to you?
Yes.
So you can attach 1 hydrogen with every single unpure electron, see? And we got the exact formula. We got the structure, a stable structure. You can see. What is this? C6H6. So we just checked that C6H6 is having different formula. This is the different formula. Oh, sorry, this is having a different structure. And definitely formula is also different. If you say, Miss, there are double bonds. So it should be hexene. because there are double bonds. So it should be hexene. Okay. But we do have a journal formula of the hexene. We do have a journal formula of alkene. And this C6H6 is not following this journal formula of the hexene, or it is not following the journal formula of the alkene. So how can we say that this is alkene? All the alkenes are following the journal formula of alkene. All the alkanes are following the journal formula of alkane. The C6H6 compound is not following the journal formula of alkane or the alkene. So this is not alkene or alkene. This is something different, a ring structure, not a linear structure. We just made the linear structure of alkane and alkene. So this is totally different. So we say that this is benzene. What is benzene? C6H6. We have to discuss a lot of compounds, not a lot, of few compounds you can say, or we have to discuss few compounds which are having ring structures. So definitely we have to make a group for the ring structures. So the group name is arenes. Arenes. Arenes means ring structure compounds. And the example is this one here, the benzene. We have to discuss more examples in upcoming classes, but this is benzene. The name of the compound, the example of the arene is the benzene. The group name is arene, alkane, alcohol, haloalkane, arenes. And what is the skeletal formula? Let me tell you. You know very well. Corners are showing the carbon. You can check, there are 6 corners. And there are alternate double bonds, so you have to make alternate double bond. Rest of the thing are hydrogen. You don't have to show hydrogen. You don't have to show carbon, but you can see there are 6 corners. 1, 2, 3, 4, 5, 6 hexagonal ring. You don't have to make this dot lines or something, but you have to show the bonding. I mean, there are alternate double bond. You have to show double bond inside the structure. This is the skeletal formula of the benzene. But let me tell you, one more thing you should know. These double bonds are keep on shifting. I mean, this double bond will shift here. So this one have to shift here. So this double bond have to shift here. Means after some time, you will see compound with the double bond here. So that's why for the skeletal structure of the benzene, we don't have to show double bond like this, because double bonds are shifting from their place. So instead of making double bond, oh, okay, forget about this thing. You have to show ring here. You have to show ring inside. What does this ring mean? This ring means, I mean, you have to make hexagonal ring, and inside the hexagonal ring, you have to show this ring. What does this circle or ring means? It means there are double bonds, but they are shifting from their places. And they are shifting from their places, or they are changing their places so fast that you are unable to check that where is double bond right now. That's how you can learn this thing. This is the easiest way to remember this point. So that's why this is the skeletal formula of the benzene. So this is another functional group, which is benzene.
Do I need to know how to draw the structural formula?
Yes. That is included. That is included because when you are going to do the reaction, so you should know how you should know that how to draw the structure of the benzene, because sometimes you have to break the bond. So you should know that which bond you are breaking and where you are attaching new things which are attacking your benzene ring. Means if you are reacting your benzene with something, so you have to join new functional group with your benzene. So you should know that where you are joining the things. Is it clear? Any question?
No.
Okay. So alkene, for the alkene, we just discussed the example of ethene. You should know about the functional group in detail, and you should learn functional group completely. Otherwise, you cannot make a single compound. I mean, if I'm giving you a reaction and you can see there are 2 reactants, so you should know what reactants are there in a reaction. You should know either this is ketone, or this is alcohol, or this is aldehyde, or this is ester, or this is carboxylic acid. So you should know that how the reaction is going to be take place, because ketones undergo with the different reactions. Alcohols have different reactions. Alkene have different reactions, alkane have different reactions. Oxidation of alcohol will give you something else. Oxidation of other functional groups or other compounds will give you something else. So you should know about the functional groups correctly. Then you can do the structures. Without functional group, you cannot do anything in organic chemistry. You know, organic chemistry is more difficult for A levels. Okay, alcohol. And what is the example? This is the ethanol, or you can make a structure for your practice of butanol, pentanol, hexanol, whatever you say. This is haloalkane. And I told you this is haloethane, or you can say the chloroethane if you want to specify. So you can say chloroethane, not ethane chloride. Chloroethane, bromoethane. Okay. Okay, I have done some spelling mistake. You can check it out. Okay, this is chloroethane. I have done some mistakes here in spelling. Okay, let's move to the next one. What next we just discussed? Benzene. That's what we discussed. And there is ring inside it. It means the double bond is shifting its places. What is the name of this group? Arenes. The ring structures are called arenes. And the name of this is benzene. Okay. So this is all about these four functional groups. The next one is